All right, in this video, we're going to solve some algebra-style problems using angles and some of the angle terms that we talked about in the previous video. All right, so first thing, we'll read our question here, read our problem. It says we want to solve for x and find the missing angles. Okay, so that's a big key. Not only do I want x, but I need to figure out what all the angles are. All right, so it tells me that ray CD is in the interior of angle ACB. And then it gives me some values for my angles. So the first thing that I need to do is I need to draw myself a picture. I'm going to draw my angle ACB. Okay, so there, let's say that's my angle. It doesn't matter what the angle looks like. It by no means needs to be 64 degrees. We just need a picture to look at. So I'm going to say that my point A is there. C is in the middle of my name, so that is my vertex. And let's say that B is a point right in there. Okay, so there's my angle. Then it tells me that I have a ray CD in the interior of that angle. So there's C, there's my ray, which makes a point on here. Okay, there it is. And that makes a point on this ray, point D. Okay, so there's our angle. That's basically what we have. All right, so it tells us what our angle values are, so I'll go ahead and plug those in and get a different color here. So it tells me that angle ACD is 3x plus 4. And then it tells me that angle DCB, so this angle down here, is 2x minus 5. Okay, and finally it tells me that angle ACB, so this entire angle right there is 64 degrees. Okay, so it gives me that angle 64 degrees. So that's what we're given. That's what we know. Okay, all right, so what we're going to do is go ahead and we'll set up our equation and we'll solve it. Let me get a smaller font size here. All right, so we have something called the angle addition postulate. It is very, very similar to that segment addition postulate, except it's basically with angles. That's really the only difference. So if I have a ray, line, or segment that is on the interior of an angle, that means that the two angles that are formed add up to the original angle. Okay, so the sum of these two angles that are formed by this interior ray is equal to the sum of the entire angle. Okay, so basically what our equation is going to look like is this. I'm going to have 3x plus 4 plus 2x minus 5 equals my entire angle 64 degrees. Okay, so from there I'm just going to solve for x. I combine my like terms, so 3x and 2x is 5x. Positive 4 minus 5, so minus 1 equals 64. I'm going to add 1 to both sides, so I have 5x equals 65. Finally divide both sides by 5, so I have x equals 13. Okay, so I've solved for x. I also need to find my missing angle value, like it says here in the problem, so I will go ahead and plug those values in. So for my angle ACD, it would be 3 times my x, so 3 times 13, plus 4. Well, 3 times 13 is 39. 39 plus 4 is 43. And then finally for angle DCB, it's going to be 2 times my x, so 13 minus 5. 2 times 13 is 26, minus 5 is 21. And if I look at my angle here, it was ACB was supposed to be 64 degrees. Well, 43 plus 21 is 64 degrees. So that's a very easy way for us to check our answers. Okay, so that's our first example. Our next example, notice we've got that term angle bisector in there, so that's going to change up the problem just very slightly. All right, so it tells us what our angle ABC is equal to. it tells us that BD is an angle bisector, and then it gives us values for angle DBA. We want to find the measure of all the angles. Now, it doesn't specifically say to solve for x. However, in this problem, in order to solve it, we do have to solve for x first. Okay, it's just whenever you submit your answers, you would only give me the angle values. You wouldn't also include the x. All right, so it says we have angle ABC. So first thing I'm going to do is go ahead and draw that angle. But notice that angle looks almost identical to the first one I drew, which is fine. And then it tells me that BD is an angle bisector. So I'm going to go ahead and draw that in there. And it is an angle bisector, so I'm going to go ahead and draw in my little arcs here so I don't forget that they're angle, but that it's an angle bisector. All right, so I need to go ahead and label my angle here. It tells me it's angle ABC, so I'm going to put angle A there. B is in the middle, so that's my vertex. And finally, angle C right there. Then it tells me that BD is my angle bisector. So then that's my point D is somewhere on that angle. Up a little bit. So we got that there. And point D is somewhere on that, right? It doesn't matter, right? It's somewhere on there. Alright, so it gave me some angle values, so I'll go ahead and plug those in. It tells me that angle ABC, so my entire angle here is 5x plus 32. That's my entire angle there. And then it tells me that angle DBA, so this small angle right here is 4x plus 4. 45. 4x plus 4. Okay, so that's what angle DBA is. Well, if these two angles are congruent, that means that angle DBC is also, let's see if I can calculate it. I want to replace that. So we know that both angles are 4x plus 4. Okay, so now we can go ahead and set up our equation. Because again, I can use that angle addition process. So 4x plus 4 plus 4x plus 4 equals 5x plus 32. Now, a couple other ways that you could have written that. You could have just done 2, and then in parentheses, and then the quantity in parentheses, 4x plus 4 equals 5x plus 32, and then just distributed the 2. That would have been fine. You could have also taken your entire angle, the 5x plus 32, and divided it by 2 to get 2.5x plus 16 equals 4x plus 4. All of those would have been fine. I wouldn't have recommended it just because you've got decimals there, and it's a little bit, but most people are just work a lot faster if you don't have to worry about decimals. So this is kind of how I would set it up. For most of y'all, I would have just done the 2 and then in parentheses 4x plus 4. That's what I would have done with the GT, but you know, it's totally up to you. So you got options. Alright, so let me go back to solving this here. Alright, so I got my 4x plus 4x, that gives me 8x. Then I've got 2 plus 4, so plus 8 equals 32. I'm going to subtract 8 from both sides, so it gives me 8x equals 24. Finally, I'm going to divide both sides by 8, so I get x equal to 3. Okay, so I have my x equal to 3. Alright, now, so from there I'm just going to go ahead and plug my values in. Ooh, you know what? I skipped a step. I apologize for that. Let me fix that here. I forgot I needed to, after I had my term, so I would have gotten 8x plus 8 equals my 5x plus 32. So I'd want to subtract 5x from both sides, which would give me 3x plus 8 equals 32. Now when I subtract 8 from both sides, I'm going to get 3x equals 24. divide both sides by 3, so I get x equal to 8. Okay? Alright, so now that I have 8, I'm going to go ahead and plug my values in just to kind of see what my angles are, because it does want me to find the measure of my angles. So I'll find angle DBA first, so that's going to be 4 times 8 plus 4. So, well, 4 times 8 is 32. 32 plus 4 is 36 degrees. And then angle DBA is going to be the same thing, so it's also 36 degrees. So if I do 36 and 36, I should get ABC as being 72 degrees. So let's go ahead and plug that in just to make sure. So I'm going to get 5 times 8 plus 32. 5 times 8 is 40. 40 plus 32 is 72, and it works out perfect. That's exactly what we should have gotten for our angle values. And then on our final example, it tells us that we have two complementary angles, angle DBA and angle ABC. Well, if they're complementary, that means that they add up to 90 degrees. Okay, so then if I've got angle, it tells me what angle ABC is, tells me what angle DBA is, I need to find the measure of my angle. Again, it's not asking us for x, but we do need to solve for it in order to plug it back in and get our values. Alright, so if we want to set up our equation, I don't need a picture in this one because it just tells me that they're complementary. So I know that if I add my two angles, 3x plus 4 plus 6x plus 7, I know that's equal to 90 degrees because they're complementary. Okay, so I can go ahead and combine like terms. 3x and 6x is 9x. And 4 plus 7 is 11. And that equals 90. Subtract 11 from both sides, so I have 9x equals 90 minus 11 is going to be 79. That doesn't work out very pretty. Let's go ahead and let's change something real quick, just to make sure it works out nice and neat. Because I'd rather have something work out a little bit neater and so we got something we can kind of talk about. We're going to make these changes in the values here, just so that it works out a little bit nice and neater so we can plug it. I don't want to mess with that nastiness there. So okay, so that's going to work out much nicer. Alright, so we did combine our like terms, so minus 4 and minus 5, so that would be minus 9. Add 9 to both sides, we have 9x equals 99. We divide both sides by 9, so we get x equal to 11. It wants us to find the measure of our angle, so we'll go ahead and plug those values in to see what we've got here. So we have 3 times 11 minus 4 equals 3 times 11 is 33, minus 4 is 29. And hopefully the value that we get adds up to 90, so I'm going to do 6 times 11 minus 5. 6 times 11 is 66. 66 minus 5 is 61. And if I add 29 and 61 together, I do get 90 degrees, which is what we're looking to get to, so we know that what we did was correct. All right, there's some examples. Sorry about that.